right, so I wanted to look at 15A. I'm just going to hold my answer key up here so we can see the chart. So I don't have to, rewrite all these numbers. So you're given values for velocity in feet per second in this table here. And what A is asking for is approximate the distance traveled in the first 10 seconds using a left sum. All right, so the first subinterval from 0 to 1, that's a distance of 1. And we're doing a left sum, so the number on the left is 45. And then the next one, from 1 to 4, that's a distance of 3. The number on the left is 40. And then from 4 to 6, that's a distance of 2. Number on the left is 30. From 6 to 7 is 1. The number on the left is 22. And then last one, 7 to 10 is 3. Number on the left is 14. That actually went okay overall. The issue I had is so many of you forgot the units, feet, which is really, really important. I want you to understand this is a velocity, feet per second. We're doing an approximation of an antiderivative. So you'd go backwards and just get feet. And so people left that off. For some reason, it was okay on the last one. Like people, whenever you approximate a derivative and acceleration, people wrote the feet per second squared when we did that slope for acceleration. But a lot of people forgot the feet there. So I just wanted to make sure I went over that. You've got feet per second, and then you've got feet per second squared. So I will now open it up to you guys. And I will take questions for a little bit. So are there ones that you want to go over? And you can type it to me privately as well. So are there any from the test that you want to go over together? All right, so 12B. And then I'll answer that next question that someone put in there. All right, so 12B is integral 0 to pi over 2 cosine of x minus x to the third dx. Darken that up. So we're going to do the antiderivative, and then it's upper boundary minus lower boundary. So we need to come up with a function that if we did the derivative, it would be cosine. It's like this is the answer and not the question. So that would be sine. Derivative of sine gives you cosine. And then minus, for the x to the third, it will be 1/4 x to the fourth, and then such that 0 to pi over 2. All right, so let me pull out my unit circle. We do upper boundary. We're going to do upper boundary minus lower boundary. When we plug in pi over 2, all right, hey guys, using a word like up, down, left, or right, where is pi over 2 on here? Good, up at the top. Nice job, guys. Perfect. I was waiting until I got a few answers there. Here's pi over 2. All right, we're going to do sine. Sine is the y value, and so that would be 1. So sine of pi over 2 is 1 minus, and then we're still plugging in pi over 2, so this looks really awkward. It would be 1/4 pi over 2 to the fourth. All right, minus, now we're plugging in 0. So where is 0 pi on the unit circle? Like if you haven't rotated anywhere, again, you can just say up, down, left, or right. Where would 0 be on here? Like no pi, like you didn't go anywhere. Good, perfect. This is like your start finish line here on the right. So here's 0 pi. Sine is the y value, which is 0. So sine of 0 is 0. I bring up going through that though, because you don't always get 0. For example, if it was cosine instead, cosine of 0 is 1. So you should still always check. Okay, but I'm done with that unit circle. So put that away. And then if we plug in 0 to this second part, that's just still going to be 0. And I was fine with you stopping there. I know it said simplify completely, but what I wanted you to do was the unit circle. Like I didn't want you to leave this as your answer, sine of pi over 2. I wanted you to tell me that that was 1. So I was fine with this, but if you did go further, this would be what? Pi to the fourth over 2 to the fourth is 16. And you could go further if you want, but if, I wanted you to do the trig is the point of that. All right, and then I had somebody say 10z. So let me go to 10. And we're going to do letter D. All right, so this was the problem integral 0 to 8 x squared plus 2 dx. So you had to make a table with all of those values. And I'm just going to go ahead and write them out real quick. You just had to plug all of these in. I'm just copying them from my answer key here real quick because this part went okay. Nobody really had a problem with this. You're plugging all these numbers into the function there. All right, and so part D was I already wrote D. Part D was the trapezoidal sum. So your formula for a trapezoid is 1/2 height and then add the bases together. And I had some people do all 4 of them separately. That's fine. To write it in the sort of factored or abbreviated way, since it's a bit shorter, you would put that 1/2 out front. And then the height is the length of the subinterval. Each subinterval in this case is 2 units in length. So from 0 to 2, 2 to 4, 4 to 6, 6 to 8, they're all 2 units in length. And then when you add up all the bases, you use the first one and the last one just once, and all the ones in the middle twice. And that's because they get shared between each subinterval. Like this 6 is shared between the first trapezoid and the second trapezoid. So this is going to be 2 plus, and then double the 6, and then double the 18, and then double the 38, and then the 66 just once. So that was your trapezoidal sum. And again, if you didn't like that, and I had people do all 4 of them separately, and that was fine too. I mean, obviously I'll mark that correct because it's the correct answer. All right, I can maybe do one more. Okay, I will do 13, and then we'll have to move on here. Actually, I'm not sure if I'm gonna have enough room here, but we'll see. Oh yeah, you know, I can fit 13 on here. All right, 13. Here is the function. And we're given the interval 0 to 2, and it says find the average value. So if I give you a list of numbers and ask you to average them, you would add them all up and then divide by what you've got. So an integral is going to add it all together. We just have to divide by the length of the intervals. So out front, you'd have 1 over 2 minus 0, and then integral 0 to 2. So these numbers should match. And then the function, and then dx. So out front, we've got a half, and we're going to do the antiderivative. So antiderivative for this would be 2x squared plus 1/3 x cubed. And then we're going to evaluate from 0 to 2. And so it's going to be upper boundary minus lower boundary. And so if we plug into, actually, I'm going to need the 1/2 in front of each of those, huh? So if we plug into 2 squared is 4, double that is 8. 2 cubed is 8, so that'd be 8/3. And then if you plug in 0 to all this, you're going to just get 0. So you actually don't even have to write that part if you don't want to. And you don't need to simplify it down. So you can just go ahead and stop there. In fact, you could just plug in the 2. I had people write it as 1/2 parenthesis 2 times 2 squared plus 1/3 times 2 cubed close parenthesis. And, you know, I marked that right because it's the right answer.